Hi, Aspen.
Hello.
So you have this test tomorrow, huh?
Yep.
You are a junior, right?
Yeah.
So you get another chance at it in the fall? Is it the first time you've taken it? Will be tomorrow?
Yeah.
Okay. Well, that'll be good to have a practice. You will get another chance in the fall, I'm sure. Regardless of what you score on it, I would think you'll probably want to take it again just to see if you can improve on it.
Of course.
All right. Well, we left off at number 10, and I'm still working from the practice test you sent me.
Yeah.
So let's have a look at 11. I tell you what, can you give me 1 minute, and if you look at 11, I'll be back in less than 60 seconds.
Okay, sounds good.
All right. So, if a B is always an A, and a C is always a B, and a D is always an A, what must be true?
An A is always a D.
No, just because a D is always an A doesn't mean that an A is always a D. In other words, a cowboy is an American. Doesn't mean that American is a cowboy.
Oh, okay.
Okay? In other words, you can't reverse it. This is kind of like saying, if P then Q does not mean if Q then P.
Okay.
Okay? However, it is like saying, if a B is always an A, and a C is always a B, well, what does that make a C relative to A? In other words, if a cowboy is always an American, and an American is always a human being, then doesn't a cowboy have to be a human being?
Yeah.
So a C is always an A. It's kind of like saying B is equal to A, C is equal to B, therefore C is equal to A. Although not quite, because these aren't equals. The key really here is to know that the answer has to be one of these three letters, is always one of these three letters. You can never go the other way.
Okay.
Okay. All right, let's see. Is 12 on this one? No, 12's on this one. All right, these are tough ones here. This one is a tough one. Hold on a moment. Pull my journal up. Fit it in there. When I say these are tough ones, any distance, rate, and time problem tends to confuse a lot of people. I would say this would be one of the tougher problems for anybody taking the test.
Okay.
What is the master equation that governs distance, rate, and time?
Rate times time equals distance?
Yeah, dirt is the way I remember that. Distance equals rate times time. Obviously, that means that time equals distance divided by rate, but don't bother memorizing any of those. You can always work the rest out algebraically. So this is the master one you always want to remember. Okay? So, I'm reading it myself now. She runs the first half of the rate at 8 miles an hour and the second half at 6 miles per hour. How many hours did it take her to complete the race? What distance did she run at 8 miles an hour?
13.1.
Okay, so let's solve that for how long it took her to run the first half of the race.
All right. So 1.6.
Okay, 1.6 hours. How about the second half of the race?
So she ran 13.1 in 6 team.
Hold on, let me let my dog out of the room. Let's go. So what is the time for the second half?
2.18.
So the total time?
Is 3.7 something. 3.78.
Interesting. Notice their answers. They have two answers relatively close together. So close together that if you've rounded off like you did, we can't distinguish them. In other words, if I add those two numbers that I get 3.78, which is precisely halfway between that number and that number. So knowing that alone, which number would you pick?
The higher one?
Yeah, because there's bound to be some digit that we left off on the first half of the time. I'll bet it's not 1.6. I'll bet it's 1.64.
Okay.
In other words, if you divide, let me do it on my calculator. 13.1 divided by 8, 1.6375. The mere fact that I know there's additional digits here means that our answer has to be bigger than 3.78. And since anything bigger than 3.78 is closer to this than it is this, I'm going to take this answer even if I didn't have a calculator. In other words, just based on the information you gave me, 1.6 and 2.18, I know the answer has to be closer to 3.82. All right. About 13. Her $20,000 a year salary increases by 10% per year. After 2 years, what will she be making? Which two answers can you immediately eliminate?
2,000 and 4,000.
Yeah. What's she making at the end of year 1?
She's making I
can still hear you. What was that?
what just happened? What is it?
Can you still see my screen and hear me?
Yeah.
Okay.
Yeah. I got the weirdest thing
Okay, if your salary goes up by 10% and you're making $20,000 a year, what do you make at the end of the first year? What's 10% of 20,000?
2,000.
So
Oh, wow.
what are you making at the end of year one?
22,000.
Okay. What are you making at the end of year two?
You're making 24,000.
Nope. What's 10% of 22,000?
2,200.
That's what you have to add to this number, which gives you 24,200. See, it's compounding. You don't make 10% of 20,000 raise in the first year and then 10% of 20,000 in the second year. You make 10% of 20,000 in the first year and then 10% of your new salary, 22,000, for the second year. The third year, your raise would go up by 10% of that. So it compounds better than just making 10% of your original each year. So we have a triangle. I'm going to draw it like a right triangle, even though this is not a right angle necessarily. But the reason I do is because I know if I draw it close to a right triangle, A and B are going to be less than C. So what must be true about A, B, and C?
A plus B is more than C.
Yes.
No.
No, you're right.
Oh.
There is a rule about triangles, and it'd be worth memorizing this rule. And the rule is pretty easy to remember, and it says any side of a triangle has to be less than the sum of the other two.
Oh.
And the corollary has to be greater than the difference of the other two. In other words, if you took a right triangle, a 3, 4, 5, you can apply this rule to any side of any triangle. The 5 has to be less than the sum of the other two, which it is, and it has to be greater than the difference of the other two. Likewise, the 4 has to be less than the sum of 3 plus 5, and it is, and it has to be greater than the difference of 3 plus 5. So you can apply this rule to any triangle. And the way to memorize this rule is just to remember that part, and then know the other half of it is just the opposite. It's less than the sum, it's greater than the difference. In other words, this is opposite, and that's opposite.
Okay.
So all you have to remember is that it's less than the sum of the other two sides, and that's what H says. A plus B is less than C. And you know, it doesn't even matter that C is the longest side. That is true of all triangles. Hold on. And now, I'm sorry about that. Let me think for a moment. C has to be less than the sum of the other two. That's G. A plus B has to be greater than C. Okay. This is a problem that we have run into repeatedly already, just in the limited amount of ACT practice we've done. So you can count on this problem being on the test.
Okay.
In one of many forms, In other words, I can draw a picture if I want. You don't need a picture here, but there's the coordinate 2, 8, and the coordinate minus 15, 8 is close to that. I can approximate. What's the midpoint of that line?
Midpoint is, so the
What's the y coordinate of the midpoint? Forget the x coordinate.
The y coordinate's 8.
Okay, that's all you need. That's all they wanted to know. However, what's the x coordinate?
The x coordinate would be negative 5.5.
6.5.
6.5, okay.
What you do is you take the sum of these two numbers and you divide by 2. So we have minus 15 plus 2 divided by 2. That's minus 6.5. The key thing is to make sure that whatever point we come up with is equidistant from minus 15 and 2. And minus 6.5 is 8.5 units from minus 15, and it's 8.5 units from 2. Okay. Now, the other form of this question is where they give you the midpoint. Let's change the question up. And I'm going to give you the midpoint and an ending point. There's the midpoint. How do you get the end point? How would I get this point here? Because that's the other form we see it in, is where they give us an end point and the midpoint, and you have to give them the other end point.
You would do like negative 15 plus x over 2 equals...
Well, just figure out the distance from negative 15 to negative 6.5. How far is that?
8.5.
And it's in a positive direction, right? In other words, it's to the right. Mm-hmm. So we have to add 8.5 to that number. That gives us 2. That's how you do it. Okay. Now, the difference between 8 and 8 is 0. So we have to add 0 to this number to get the other midpoint, or to get the other end point. Okay. So you definitely want to be able to go both directions on that. Let's see. Now we've finished with the 4 documents that you sent me last time. I still have the 4 original documents that you sent me, which are heavy in geometry. Yeah. Want to go over and finish that?
Yeah.
I don't know where we left off. We only have like 12 minutes, so let's start from the back and work forward, and that way we will be sure not to duplicate anything. In fact, we can start on this page. I know we didn't get to this page. So let's start with 51. Excuse me. There you go. Perimeter of a square is 3x. Then in terms of x, what is the area? What's the first thing you need to do? All of these geometry problems are always multi-step problems. You can count on not having a single geometry problem that you can solve in one step. You always have to do at least something before you can get to the answer. Okay, what's the something we need to do first? Know the perimeter is 3x. What else do we know about that square?
That it would, I don't know.
What is each side of that square if the perimeter is 3x? How many sides are on a square?
4.
So what's each side?
Each side would be 1/3 x. No.
3/4 x. Divide the perimeter by 4, and you always get the length of any side.
Okay.
So this side is 3/4 x. Each side is. Now
Okay.
that I know the side length, I know everything there is to know about this square. What's the area?
9x squared over 16.
Yeah. Reduce the size of this a little bit. All right. Remember that single thing, though, that in almost every geometry problem you're going to come across, you're going to have to do something else before you can get the answer. It's always going to be at least 2 steps. They're saying that X is the midpoint of CD.
Okay.
And Y is the midpoint of AD. And they want to know XDY.
Oh, the
XDY, what is the perimeter of that triangle?
perimeter is 12.
So this is 4, that's 3, that's 5. You're way ahead of me. Okay. Good. 1. There was actually a 1. This is the first 1 we've seen. Problem 1. What's a rhombus?
The thing that looks like a diamond.
What's the definition of a rhombus?
2 equal sides and then 2 other equal sides.
That's a kite. That's a kite.
Oh.
A rhombus is a kite, only all 4 sides are equal. So the definition of a rhombus is all 4 sides are equal. In other words, a square is a rhombus. But a rhombus isn't necessarily a square. Well, I just drew a rhombus. That's a parallelogram, but it's not a square, but all 4 sides are equal.
Okay.
So that's what you need to know about a rhombus. Now, they're giving you 2 sides in terms of a variable. How do I solve for x? Give me the equation to write. Always write an equation. Don't try to just solve it. Everything in your head.
You do 4x minus 2 equals 3x plus 3.
Now solve that.
X minus 1 equals 3x. So x equals 1?
No. When you are solving an equation, if you have a choice, always try to leave everything positive. Try not to deal with negative numbers if you can avoid it. Well, how can I not deal with negative numbers here? Should I bring the x's to the left and the numbers to the right, or the reverse?
Yes.
Okay, when I bring the x's to the left, what do I get?
X minus 2 equals 3.
Okay. And now I bring the numbers to the right, what do I get?
X equals 5.
All right. You don't always have to have x on the left and your numbers on the right. It just makes just as much sense to keep x on the right and the numbers on the left. In other words, if I switch these two things around, then I'm going to take the x's to the right and the numbers on the left because it keeps everything positive. And the less you deal with negative numbers, the less mistakes one makes. Let's start with a triangle. What's the sum of the interior angles of a triangle?
180.
Now, by exterior angles, they mean these. What do you suppose the sum of the exterior angles is?
360.
Always. That's for any polygon. The sum of the exterior angles are always 360. In other words, that plus that, they're all obtuse angles here. They're going to add to 360. So what kind of figure must they be talking about if the sum of the exteriors equals the sum of the interiors?
Four sides?
Yeah. A square would be like that. The sum of the interiors of actually any quadrilateral is 360. And since we know that the sum of the exteriors is always 360 regardless of whether it's 3, 4, 5, or 17-sided, then it has to be a four-sided figure. Not a square necessarily, but it has to be four sides. In other words, even if I have a parallelogram like that, as long as it's four sides, I know the interior is 360 and I know the exteriors are always 360 no matter how many sides there are. All right, I think we got time for this last one.
Let me think. All right, so hold on. 8. $65.
Correct. Why is that?
Because the angles all have to add up to 360.
All you need to know. That's one of the few geometry problems that's one step. Most of the time, they're never one step. Let's do this last one since that one was pretty short. The area of a square is represented by K. What is the perimeter of this square in terms of K? Well, there's my square. Area equals K. Two-step problem. What's the first thing you need to figure out?
The length of one side.
Correct. What is it?
K/4.
No. If the perimeter was K, that would be true. But you don't get an A, you don't get the area by adding up all four sides.
The square root of K.
There you go. So one side length is the square root of K. How many sides are there in a perimeter?
4.
So the answer is
4 times K squared.
4 square root of K.
Yeah.
That's what you meant. All right, let's see. That finishes that document. So we've gone over these two practice tests you sent me last time. Plus, we've gone over ACT 3. So we've almost gone over. The ACT 4 is the only one we didn't cover. But I suppose we probably won't be covering it for a while, huh? We're only taking this test tomorrow and then again in the fall, probably.
Yeah.
Yeah, well, you know, it's really worth, I really want to encourage you to get my help when you take these tests, just because the results of these tests, particularly the math portion, is as important as your entire grade point average.
Yeah.
Not just your grade point average on your math class. This is way more important than that.
Okay.
Just can't stress how important your results on either the ACT or the SAT are going to be on whatever college you apply to.
Right.
I get a lot of students that I'll work with them in a math class for 6 months, and then they work with me one time before their ACT, and that doesn't make any sense.
Right.
Let me help you more. I can help you a lot on these. So think of that.
Okay.
I mean, we've done all we can for your test tomorrow, but when you take it in the fall, remember that.
Okay. Sounds good.
All right, Aspen, I will talk to you. Let's see. Are we going to have a Thursday or a Wednesday session this week?
I think just Wednesday, because since we have the ACT out of the way, I don't think I need the Thursday anymore.
Okay. I'll go ahead and cancel that one now and in the future. So I've still got you down for a Monday and a Wednesday session every week. If that should, just let me know.
Okay. Thank you so
All right,
much.
you're welcome. I'll talk to you on Wednesday, and good luck on that test. Get a good night's sleep tonight.
Thank you so much.